Done. For this one here, we're looking at implicit differentiation. When you have implicit differentiation, that means that we have y's and x's all mixed together. So that means every time we take the derivative of something with a y, it's going to wind up also being multiplied by dy dx. So let's start with the first term, x squared. Well, that's just 2x. Minus 3. Well, the derivative of natural log of y is going to be 1 over y times dy dx. Derivative of 2y squared is equal to positive 2, or y squared, pardon me, is equal to 2y dy dx. The derivative of 25 is just 0. We want to group our dy dx's on one side and everything else on the other. So I'm going to put dy dx here on the left. And those pieces are going to be 2y minus 3 over y. And that's going to be equal to negative 2x if I move the 2x over to the other side. Now when I look at these fractions and I want to get dy dx by itself, it'd be so nice if it was just one fraction. So let's put those together. If 2y minus 3 over y needs to be something with just one fraction, then I need a common denominator. The denominator of here is 1. So I'm going to multiply by y on top and y on bottom, which gives me 2y squared over y minus 3 over y. So I can make that into one fraction. So now I have dy dx times 2y squared minus 3 all over y equals negative 2x. How do I get rid of this? On both sides I'm going to multiply by the reciprocal. Gives me y over 2y squared minus 3. So on this side I'm going to multiply by y over 2y squared minus 3. And on the left side everything reduces down to 1. We're left with just dy dx. On the right side we have negative 2xy over 2y squared minus 3. Now something tricky that a lot of times they do in AP Calculus and other math is when you have a negative here and you got a difference in the bottom, there's two ways you might have come up with an answer. If you did your problem differently, but you came up with 2xy over 3 minus 2y squared, that's the same thing. Either one of those answers would be correct. Now I kind of ran out of space over here. Let's mark off some space so we know exactly where we are. So for number 19 it says relative extrema. What does relative extrema do? It means first find critical points from derivative. Second, test them. So the derivative, if u equals x squared plus 4x plus 6, then u prime equals 2x plus 4. So when I'm looking at y primed, or dy dx, y prime equals u prime over u, which would be 2x plus 4, over x squared plus 4x plus 6. There's two possibilities for it to be a critical point. Either the numerator equals 0 or the denominator equals 0. Well, I know, just from my own experience, that this bottom piece doesn't have any roots. You could even check that by doing the discriminant, doing b squared minus 4ac, and you would find that it's an imaginary number. Therefore, this bottom never equals 0. Never equals 0. Unless you use imaginary numbers, but in calculus we don't. This top, however, can equal 0. When does 2x plus 4 equal 0? 2x plus 4 equals 0 when 2x equals negative 4, or when x equals negative 2. So there's my critical point. Now I just have to test it. So I have x, f prime of x, or y prime actually is what we're looking at. Let's keep it consistent for the problem. Y prime and then y. We want to look at -2, but we want to look before and after it. Before, we can use -3. After it, let's use 0, just because it's easy. If I were to plug in -3 into the derivative up here, -3 squared plus 4 times -3, that's 9, minus 12 plus 6, that's positive on the bottom. 2 times -3 is -6 plus 4, that's negative on top. So a negative over a positive would be negative. That means that the original function is decreasing. And you can almost assume, but when I plug in 0, just to check, I'm going to have positive over a positive. This is going to be positive. That means it's increasing. So at -2, when the slope is 0, we have a min. There's a min at x equals -2. Now the one piece that usually you would do from here is you'd plug -2 back in and actually find the y value. I'm going to go ahead and skip on from that just for time's sake, and especially just to get into this next one. It's a little more like what I wanted to show you. It says find the equation of the tangent line to y equals 4x squared minus natural log of x at 1, 4. Well, in order for me to do this for the tangent line, I need the slope, because the tangent line is really just y minus y1 equals m times x minus x1. Here's my x1 and y1, but I need to know the m, and m is the slope of dy dx at 1. Let's find y primed, or dy dx. 4x squared, the derivative of the first term is just 8x. The natural log of x, the derivative of that, is going to be 1 over x. Using these two pieces here, all I got to do is evaluate dy dx at x equals 1, which is really just going to be 8 times 1 minus 1 over 1, which equals 7. That's our slope. So the equation of the tangent line is going to be y minus the y value, which is 4, equals the slope times x minus the x value. On a multiple choice test on the AP Calculus exam, a lot of times they don't leave it written like this, but if they were to change it then to slope-intercept form, we distribute the 7, move the 4 over, and combine like terms, we'd have 7x minus 7, y minus 4 on this side, add 4, y equals 7x minus 3, but this is algebra 1. This is too easy to be worried about this step. If you guys got it to here, you should be good. The rest is